Let's see the sum. It says a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. Now, seems to be very difficult. It is talking about speed, time, distance, everything. So, you get confused. Don't worry. It's very simple. Let's observe. Let's understand first what to draw. Then we'll think how to solve it. First, it says there's a straight highway. So, there's a straight highway. Leads to the foot of the tower. So, there's a tower you can see. A man standing at the top of the tower. So, there is a man standing at the top of the tower. If you observe, that's the observer. But you don't have the height of the observer. So, that man is going to be taken as a point. On the top of the tower, observes a car at an angle of depression. So, since the observer is there, from that point, there is going to be a horizontal line. The first thing, right? And from there, he is observing that car and making an angle of depression, because this line of sight is going to be below the horizontal line. So, it is going to be like this, and that angle of depression we know is given as 30 degree. Simple, you understood this much? Beautiful. Now, which is approaching the foot of the tower with an uniform speed. That means they are saying that we don't know the speed of the car, but the speed remains constant throughout. And with that speed, it is approaching the foot of the tower. Right? So, it is continuously going to move and it is going to reach the foot of the tower. Let's see further what it says. It says 6 seconds later. That means after 6 seconds, the angle of depression of the car is found to be 60 degree. That means after 6 seconds, right? That means for that 6 seconds, the car would have moved, right? So, that means let's say the car is moving for the next 6 seconds. Observe very carefully. Yes. And it reaches the point. From that point, at that particular point, when the observer is observing this car again, this time the line of sight makes an angle with the horizontal line. That angle of depression here is given as 60 degree. Wasn't that interesting? Very nice, right? Beautiful. So, good observation. So, you have an angle of depression as 30 and then coming to 60. The sum says further, find the time taken by the car to reach the foot of the tower from this point. So, from this point, if the car has to reach the foot of the tower, how much more time will it take? That means to reach that particular point, how much seconds more it will take. That is what we are supposed to find, right? Isn't that interesting, right? We have taken those points now. Observe, like we do any sum based on angle of depression, we need to get those angles into the right angle triangles. Let's do that now. So, if you observe angle EBD and angle BDA, those two angles, what type of angles are they? Yes, we know they are alternate angles. And what do you know about these alternate angles? You know they are going to be equal because the lines are parallel. So, we have that angle BDA to be 30. Similarly, you get one more information. Yes. Now, look at angle EBC and angle BCA. Those two angles are what type of angles? Alternate angles. Yes. And what can we say about them? We can say that they are equal. So, we take them equal and that is again 60 degree each. Right. You got this. This is what we have formed. And now in the sum, what they say is we need to find the time taken by the car. So, you know the time is nothing but it is distance upon speed. So, students, what we need to do in the sum is if you want the time taken by the car to move from C to A, which we need to find. So, we need to get that distance from C to A, that is CA, and the speed at which the car has traveled. But remember, the speed at which the car has traveled from D to C and C to A, the speed remains the same because there was a word given, uniform speed. So, that speed from D to C, if we can get, that is going to actually get us the time from C to A. Observe. Now, how are we going to do this? Let's do the few descriptions here. Now, here we can say that AB represents the height of the tower and we have taken it as H. Okay. The next thing which we write here, AC. AC is nothing but the distance of the foot of the tower to the car at point C. Right. And let's say we take that as Y. And there's one more, that AD. Instead of taking AD, let's say we take that part CD. Right, because that has taken 6 seconds. So, let's represent that and let's say we say that that distance is nothing but it is X meter and that is the distance which was covered in 6 seconds. So, if we written this much in the sum, let's say, now we have a right angle triangle. So, observe that right angle triangle. It's very easy. That is what we do. So, in that right angle triangle BAC, we observe we have an acute angle C. For that acute angle C, we have that AB taken as H, that is opposite side, and we have AC which is taken as Y, which is adjacent side. That means we are talking about opposite side and adjacent side. So again the same ratio, what is that? Tan. So tan of 60, and from tan of 60 we'll get AB upon AC. You know tan 60 is nothing but it is root 3. So we write root 3 is equal to AB, which is H, upon AC, which is nothing but Y. So when we solve it further, now we get that H is equal to root 3Y. Remember, this is a common side for both the right angle triangle. I've always said that's the most important thing. That is something which will help you in the sum further. Now, you have another right angle triangle. You'll say it's so easy. Yes, let's do that. So, in the other right angle triangle BAD, take an acute angle, that is D. So, for that acute angle, opposite side is AB and the adjacent side is AD, right? So, again, it is opposite side upon adjacent side. So, which ratio? Yes, it is tan. So, we write tan of 30 is equal to AB upon AD. Tan 30 from the trigonometric table, yes, students, we know it is 1 upon root 3. Right, 1 upon root 3 is equal to AB. What is that? It is nothing but H upon AD. What's the value of AD? If you look at the figure, you will come to know that AD is nothing but X plus Y. Beautiful. So again here, when we solve it further, so we get X plus Y is equal to H into root 3 when we cross multiply. But from the first equation, we have that value of H. So we can substitute that value of H from first equation. So we write there root 3Y into root 3, right? So we get X plus Y is equal to root 3 into root 3 is 3, right? So we get X plus Y is equal to 3Y. That means Y goes on to the other side. So we have X is equal to 3Y minus Y. That means we get X is equal to 2Y. And let's say that is our equation number 2. Now students, this is very critical. Now you got some information about that distance between C and D, that X, which is nothing but equal to 2Y. Now from this, you can get the speed of the car from C to D. And if you can get that speed, that is going to help us to find the time between E and C. Now I'm going to leave you here, think over it, find the speed between C and D, and then you'll get the time from A to C. I'm leaving you here. I want you to solve it. I'll be back with the answer.